Just a minute. Okay, so here in the test, basically you have to mention the x ordinate for the x2 grid. Okay, now what is the x ordinate for the x2 grid is this is nothing but the distance of x2 grid from the x1 grid. So you can see the distance between these two grids is like 4100 mm. Okay, so this is nothing in the structural plan. Basically the distance are in mm. Okay, but in the Etabs we have to provide the distance in the terms of meter, right? So just divide it by 1000, so you'll get the distance in the meter terms. So it will be 4.1 meter, right? Then after x3 grid is there. Okay, now this is the last grid in the x direction, and x ordinate for the x3 grid you have to provide. Okay, now the x ordinate for the x3 grid is nothing but the distance of x3 grid from the x1 grid. Okay, distance of x3 grid from the x1 grid. So this will be equal to 4100 plus 4100. So it will be 8200 mm. And if you just take it in the terms of meters, so that will be 8.2, right? So here x ordinate for the x3 grid is a 8.2. Then after there is no another grid after the x3 grid. So here you can just delete this. Okay, just select this one and just click on delete, and this will be deleted. Now then after you have to provide the grids in the y direction. Okay, these are the y grid data you have to provide. So let's say these are the grids in the y direction. So the first y1 grid is there. So we'll mention that in the Etabs y1, and the x ordinate for the first grid will always be a 0. Sorry, y ordinate for the first grid, this will be 0 only. Then after the y2 grid is there. So grid ID I will take it as a y2. Then after distance of a y2 grid from the y ordinate we have to mention. So it is like 5700 mm. So in the meter terms it will be 5.7 meter. Okay, a y ordinate for the y2 grid is nothing but the distance of y2 grid from the y1 grid, and it is 5.7 as per the structural plan. Then after y3 grid is there, and the distance of y3 grid from the y1 grid you have to mention. So 5700 plus 3100, how much it will be? Okay, 8800 mm. Now in the terms of meter, that will be 8.8. Okay, then after y4 grid is there. Okay, now y4 grid, the y ordinate for the y4 grid is nothing but the distance of y4 grid from the y1 grid. So it will be equal to 5700 mm plus 3100 mm plus 5700 mm. So that will be 14,500. So that will be 14.5 meters. Okay. Do you have anything to ask about the ordinates and the grid data?
No, it's clear. It's clear. So far, it's clear.
Okay, fine. So then after, once you provide the grid data for X and Y, then just click on OK, and OK here also. I'll close this Model Explorer window and this 3D view window. Okay, see, once you have provided the grid data, let's say after some time you want to change the grid data also, like you want to change the grid spacing or not. So in that case, what you can do is you can just go for the edit and then edit storage and grid system. Just modify the grid data here and you can change it. Okay, so once we provide the grid data, the next thing we have to mention is the number of stories, like how many numbers of stories are there in the particular building and what is the height between every particular story, that we need to mention. So for that one, we have to go for the edit and then edit stories in grid system. Then after we have to go for the modify or show story data. So by default, the Etabs will take 4 stories. Okay, this base is nothing but the foundation. Okay, you can just change the name also, foundation. Okay, then after, let's say story one, this will take as a ground floor. Okay, then after, this one will be the first floor and the second floor. Then after the second floor, there will be a terrace level, right? So this is the terrace level. Now you need to provide what is the distance between the ground floor and the foundation level. Okay, so basically this is the G+2 building, right? So it will require, let's say it will require a shallow foundation. Okay, and the typical depth for the shallow foundation is less than like up to 1.5 meters only, right? So we can take the elevation height of a ground floor like from the foundation as a 1.5. Okay, basically this is the height of a ground floor from the foundation level, which is 1.5 meter we have taken. Okay, and let's say from the ground floor to the first floor, the height is 3 meter, and the second floor is having the height of 3 meter from the first floor. Same goes for the terrace level also. Okay, according to the height you mentioned for every particular story, the elevation height will be automatically calculated. Okay, now there is a master story option here. Okay, let's say you take the ground floor as a master story. Then what you can do is, whatever the modeling you do, like whatever the changes you will do in the ground floor, the same changes will be made on the remaining floors also. If we just take here, if we just take similar to option, and here if you select the ground floor, then whatever the changes you do on the ground floor, the same changes will be made on the first floor also, because you have selected the first floor similar to the ground floor. Got it?
Yes, clear.
Okay, so for this one, we are going to always take this as a none only. We are not going to take any particular story as a master story. So I'll select a none here, and then okay. Rest of the things, these are not important. So I'll click on OK and OK. Okay. Now here you can see here, these are the three options. You can click on this 3D just to get the 3D view. Okay, you can click on this plan just to get the plan view of the any particular store. You can go for the foundation, click on apply. Then you can go for the ground floor, you can apply. Okay, the same is there because only the grid system is there. We have not done any particular structural modeling here. So I'll click on OK. So here, after specifying the grid data, the next thing we have to do is we need to check whether the grid spacing we have provided, is it correct or not as per the structural plan. Okay. So here, as you can see, this X1 and X2 grid, the distance between these two grids is a 4.1 meter. Okay, the same is there in the Etabs also. Now X2 and X3 grid, the distance is 4.1 meter. The same is there in the Etabs. So X grid data is okay. Now let's check for the Y grade data also. So 5.7 meter distance is there between the Y1 and Y2. So it is 5.7 here also in the Etabs. So it is fine. Now distance between the Y3 and Y2 is 3.1 meter. The same is there in the Etabs. And from Y3 through Y4, it is 5.7. Okay. So the same is there. So grid data are okay. And now the next thing we have to do is we have to define the materials. Okay, like the many kinds of material we are going to use for the structural design. Okay, like we are going to use the concrete and the steels and all, right? So we have to define those materials also in the data. So for that one, we have to go for the define section and then material properties. Okay, then after, by default these are the materials are there called by default the Etabs will add these materials according to the code you select. Okay, so let's say this is the 4000 psi is there, which is the grade of concrete only, and it is going to have the compressive strength of like 27.6 Newton per mm square. Okay, so we are going to use this particular grade of concrete only for the structural design. Then after, the grade of steel is there. Okay, so for like we use ASTM A60 as A615. Okay, which like this A615, this is the typically like mostly used for the structural design in the UAE or for the or US you can take. Okay, so here this one you can see A615 grade 60. Okay, this is the grade of steel only. Now if you want to add a different material, then you can just click to add new material, and here you can select the region according to your preferences. Let's say if you select United States, okay, then here you have to select whether you want whether you want to add the steel property, concrete property, aluminum, okay, cold form, rebar, tendon, masonry walls, and others. Okay, the difference is if you select the steel, you will get the lower grades of steel. Okay, and if you select the rebar, you will get the higher steel balls. Okay, like the higher grades of steel. So here the standard is nothing but this one, the typically used like ASTM A615. So we are going to use that only, and this is the grade 60 steel is there according to the ASCA. So here this grade 60 steel, this is going to have the tensile stress of 620 Newton per mm square, right? So that one only we are going to use, and it is by default it is defined in the Etabs also, so we don't have to add that one. So here 4000 psi, this is the grade of concrete, and this A615 grade 60, this is the grade of steel we are going to use. Okay, we are going to use a different material also for the second project. So for now, these are the materials we are going to use for this particular projects, and I will just click on OK. Then after, we have to define the section properties, like what are the sections we are going to use for the structural design. Like we are going to use the slabs, columns, beams, and all, right? So we have to define those sections also. So for that one, we have to go for the define section, and then section properties, and then for the frame section, we have to use a frame section option when we want to define the beams and columns. Okay, so let's just use this frame section, and by default you can see there are lots of section here. Okay, but you can add any particular size of section according to your preferences. So what you have to do is you just have to click to the add new property. Okay, and here you have to select the section shape. You want to take the rectangular or the square. Okay, you can take concrete rectangular, you can go with the circular also. Okay, you can see the circular is there, rectangular is there. Okay, let's say I want to design I want to take the concrete section which is rectangular. So you can use this. Okay, let's say I want to take the property name. Let's say I want to define the column property, right? So I will give it a name as COL, which is column. Okay, then after I will specify the dimension of the columns, right? So here the dimension of the column I have taken for the structural plan is like 230 by 500 mm. So 230 by 500 mm. Okay, the property name you have to provide like whether it's a beam or column, and then after you have to provide the section size also. Then after the material you have to select. Okay, material you have to select that will be the grade of concrete, which is 4000 psi. Then after, what you have to do is you have to provide the depth and the width for the particular section. Okay, here width is nothing but the shorter dimension, lateral dimension you can say, which is 230 mm, and depth will be larger dimension, which is 500 mm. Okay, then after what you have to do is just modify this reinforcement section so that you can just change the reinforcement according to your preferences, right? So here design type, if you are defining the column property, then you need to make sure that the design type should be column. Okay, and if you are defining the and for the rebar material, you need to make sure that the longitudinal or the stirrups should be of the grade of steel only, like A615 grade 60. These are the grade that is by default defined by the Etabs only. Okay, these remaining parameters like the longitudinal bars, confinement bars, these don't need to change it. Okay, these are not required to change as of now. Once we get to the design of the particular members, then in that case only we can just change these parameters. So as of now, we are going to leave it as it is. Click on OK. Okay. Let's say I want to define the concrete beam also now. Okay. You can use one shortcut here also. If you want to define the concrete column property, what you can do is you can see this concrete column. Just select this and just click to add a copy of the property. Okay. You can just provide the property name and the dimensions here. Okay. The property will be defined. Now we'll use this same shortcut also for the beams also. So what I will do is, let's say I want to define the beam property. So I will select this concrete beam. Then after, I'll just click to add copy of the property. Okay. Now according to the structural plan, the beam size we have used is a 200 by 500 mm. Okay. So we are going to define the same size of the beam in the Etabs also. So I will give the property name as a BM 200 by 500 mm. Okay. Now the material will be the grade of concrete, which is 4000 psi. Then after, section shape, that will be the concrete rectangular only. Depth is a 500 mm, which is the larger dimension, and the width is nothing but the shorter dimension, which is 200 mm. Then again, we need to modify the reinforcement section so that we can change the reinforcement and all. So here, as we are going to as we are defining this beam property, so we need to make sure that the design type should be beam. Then after, a longitudinal bar should be A615 grade 60, and this tear-ups also A615 60. Then also here we don't need to change any kind of cover here. We will leave it as it is. I'll just click on OK and OK. So as of now, we have defined the column property and the beam property. The next thing we are going to define is a slab property. Okay. So in the Etabs, basically we have to define slab properties like the normal floor slab and the staircase slab. So that one we'll define in the Etabs. Sorry. So we'll go for the define and then section properties. Then after we'll go for the slab sections. Okay. I'll just click to add new property. Let's say I'll take, according to the structural plan, we have used slabs 150 mm thickness. For the all slab, we have used the same thickness only like the 150 mm. So I will give it a name as slab 150. Then after, slab material will be the grade of concrete, which is 4000 psi. Then after, the modeling types are here. Okay. So as of now, I'll just give you the overview of this one. We'll talk about this in a very detailed way once we get to the second project. So shell thin is there, shell thick, membrane and layered. Okay. These are the...
Yes, these things are a little confusing. So as you said, we will discuss later. So I will be waiting for these things.
Yeah. I'll just give you the brief about this particular modeling types now.
All right. Okay.
Yeah.
Okay.
So for now, I'll just tell you the function of this particular. Okay. And we'll talk about this very in a detailed way for the second project only. So here, a modeling type for shell thin is there. Okay. Basically, these all are nothing but the shell elements. Okay. So here, shell thin is there. Shell thin we have to use for the floor slab modeling. Okay. Like we provide the 4 slabs and all. For that particular, for the shear wall also, we have to use this shell thin element. Then after, the shell thick is there. Okay. Shell thick we have to use for the few structural elements, like for the drop panel. Okay. Like for the pedestal in the footings. Okay. Like we provide the pedestal above the footing and below the column, right? So for that particular pedestal, we have to use a modeling type as a shell thick. Okay. And in the flat slab building, we provide a drop panel above the column and below the flat slab, right? So for that particular drop panel, we have to take the modeling type as a shell thick. Okay. And third one is a membrane. Membrane we have to use for the modeling of the staircase or the ramp slab. Okay. Then after, the last one is a layered. Now this layered we don't use anywhere in the structural modeling. This basically layered is nothing but the imaginary slabs. Okay. You can draw it anywhere on the structure. But here the layered slab, basically it does not consider its own weight. Okay. Like whatever the external load you apply on that particular slab, that will be particular load will be transferred to the surrounding supporting elements. Okay. So layered slab will transfer the external loads to the supporting elements. It will not consider its own weight. And this membrane element we have to use for the modeling of the staircase or for the lamp. Then after, a shell thick is there, which we have to use for the modeling of the drop panel, or you can say the pedestal for in the case of flat slab building, or for the footings also. Then after, shell thick is there, shell thin is there, that one we have to use for the floor slab modeling. Okay, so this slab 150 is the shell thin only, so we are going to use this one shell thin only. Okay, are you clear about this?
Yes.
Okay, so shell thin we are going to use for this normal floor slab. Then after, here type we have to use as a slab, and then after, a thickness is 150 mm. Then after, I'll just click on OK. And this is the property we have defined for the floor slab basically, right? As we have taken the modeling type as the shell thin, that is for the normal floor slab. But in the structural plan, there is a staircase slab, and for the staircase slab, we have to use a different modeling type. So here we have to define the different slab section for the staircase slab. So what I will do is, I'll just select the slab 150 and I'll take the copy of the property. Here I will